So, now that you are familiar with all the basic tools you need, let's start to solve some challenges with functional programming. Say we have an input string holding some comma-separated numbers. We would like to parse it and calculate the product. First, we need to split the string on the commas. So let's use the Functional Plus API search website to check if there already is something that can do this. Indeed, there is, and it looks quite easy to use. The function split takes a separator and a sequential container, like a string in our case. Additionally, it wants to know if we allow for empty strings in its output. We could write this function on our own now, but why not use something well tested and generic if it already is there? This method of working is the spirit of FP, since it is about composing simple, reusable elements. Internally, this function perhaps operates imperatively, with a loop or something, but we as its users do not have to care as long as it is pure to the outside. Okay, so we use it to split our input into parts. But our parts are still strings. In order to be able to multiply them, we need to convert them to integers first. Implementing string to int is trivial, so we just take it as given. Also, let's not think about ill-formatted inputs for now. We will revisit our code and extend it for these cases in a later lecture. Now we need to multiply our parsed numbers with each other, of course without writing a for loop. So, what do we need? We have a list of things and want to combine them all with an operator, in our case multiplication. This operation is called reduce in functional programming. The type signature looks complicated at first, but actually it is quite simple. Reduce takes a binary function combining two values to one, an initial value and a sequence. For multiplication, the neutral element is 1, so we use it as our initial value. As the binary function, we use std_multiplies from the STL. Now we just print out the result and we are done. Let's give it a test run. It works perfectly. This is a quite nice and concise solution, isn't it? Here is an exercise for you. Modify the code so that the numbers are not multiplied but added. Additionally, change it so that it works with floating point numbers too. For this you should pass doubles instead of ints.